In this problem, we will analyze this beam using moment distribution method. This is the beam with A and D fixed, B and C on pin support. There are point load of 20 kN, 25 kN, and a distributed load between C and D. The moment of inertia of different segments A, B, B, C, C, D are different. So we will know later how this will affect the moments at the joints. So the first thing is to calculate the fixed end moments. So for the AB, we will change the B pin support to the fixed support and calculate the AB using the formula. So the fixed moment of AB is minus 10 kilonewton meter. Similarly for BC, we will fix the ends B and C. But the problem here is that the point load is not in the center. So the formula changes. It is minus W AB square by L square. Or if you want to calculate the fixed end moment MCB, it is WA square B upon L square. So this is how we calculate the fixed end moments in BC. Similarly for the CD, the force distribution is here. So the formula is minus WL square by 12. Now we have to calculate the coefficient of stiffness. So just a second. For the joint B and C, the members BA, the K is 4EI upon 4 since the I was 2I. So this is how we calculate the K, summation of K and the distribution factor. Now here we made a table at the joints ABCD and we shown all the members AB, BA, BC, CB, CD, DC and the distribution factors. The fixed end moments which we calculated are also shown here. Now we have to use the standard method, and that is the first distribution, then carryover factor, then second distribution, and so we have to calculate the final moments. This is how I calculated it. So we got all the moments. So now we have to find out the reactions. So to find out the reaction at A, we will take the moment about B, and to find out the partial load at B, we will do the summation of B equal to 0. Similarly, to calculate the partial load at B, we will take the moment about C. And then to calculate the partial load at C, we will do summation V equal to 0. Also, then we'll take the moment about D to calculate the partial reaction at C, and then we'll calculate the reaction at D. So this is how we got the reaction at ABCD. Then we can calculate the shear force diagram and bending moment diagram, and it can be shown in this figure. So this is how we analyze the beam using moment distribution method.